Now that we have an idea of what the inverse matrix is and this idea of elementary matrices, let's look at actually finding the inverse. And we're going to start with the 2 by 2 case. If we have a matrix A given by A, B, C, D, then A inverse is given by 1 over AD minus BC times the matrix D, negative B, negative CA. And if that term AD minus BC is equal to 0, then the matrix is singular. It doesn't have an inverse. And while I'm not going to prove that this formula holds right now, a little bit later in the video when we start talking about larger matrices, I'll discuss how to go about proving that this is the case. Let A be the matrix 4, 6, 1, 2. And I want to find A inverse. We need to start by finding this term AD minus BC. And this is essentially cross-multiplying in my matrix. For AD, I have 4 times 2. And for BC, I have 6 times 1. So AD minus BC is 8 minus 6, or just 2. Now that we have that, we can start actually forming the inverse matrix. It says 1 over this term we just found. So that gives me 1/2. The first row is given by D, negative B. So D is 2, and B is 6, so I would need negative 6. The second row is negative CA. C is 1, so I need a negative 1, and A is 4. I can then go ahead and do this scalar multiplication to get the actual inverse, which is given by 1, negative 3, negative 1/2, 2. While there is a nice formula for the 2 by 2 case, larger matrices are a bit more complicated. So an n by n matrix A is going to be invertible if and only if it's row equivalent to I, which is something that I'll prove in a later video. But in this case, any sequence of row operations that reduces A to I is also going to transform I into A inverse. And this is a direct result of this idea of elementary matrices and the fact that A can be decomposed as a product of elementary matrices. So essentially, when we solve these problems, I'm going to set up an augmented matrix where my matrix A is on the left and my identity matrix is on the right. I want to use row operations to transform this into the augmented matrix I on the left and the inverse on the right. So we'll do this by using row operations to reduce A to I, and then this A inverse is going to pop out on the right-hand side. So let's look at some examples. So here is a 3 by 3 matrix, and I want to find the inverse if it exists. So to start with, I need to form an augmented matrix with this matrix on the left and the identity matrix on the right. And now we can start using our row operations. We start by getting a 1 in the first row, first column, but we already have that. So the next step is to get zeros below. To get the first 0, we'll do 3 row 1 plus row 2. And in this case, my first row is not going to change. I then have 3 times 1 is 3, minus 3 is 0. 3 times 0 is 0, plus 1 is 1. 3 times negative 2 is negative 6, plus 4 is negative 2. 3 times 1 is 3, plus 0 is 3. 0 times 3 is 0, plus 1 is 1. And 0 times 3 is 0, plus 0 is 0. We'll now move down to my third row. In order to turn that into a 0, I need to do negative 2 row 1 plus row 3. So negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 0 is 0, minus 3 is negative 3. Negative 2 times negative 2 is 4, plus 4 is 8. Negative 2 times 1 is negative 2, plus 0 is negative 2. Negative 2 times 0 is 0, plus 0 is 0. And negative 2 times 0 is 0, plus 1 is 1. I now have my first column exactly the way I want it to be. Moving on to my second column, my first step is to get a 1 in the second row, second column. That's already done for me. I need zeros above and below. We can already see we have a 0 above, so we just need to get the 0 below that 1. And we'll do this with 3 row 2 plus row 1. My first and second row will not change here. I then have 3 times 0 is 0, plus 0 is 0. 3 times 1 is 3, minus 3 is 0. 3 times negative 2 is negative 6, plus 8 is 2. 3 times 3 is 9, minus 2 is 7. 3 times 1 is 3, plus 0 is 3. And 3 times 0 is 0, plus 1 is 1. My second column now looks exactly the way I want it to, and I can move to my third. The first step is to get a 1 in the first row, first column. And I'll do this by multiplying the third row by 1/2. I know the first and second row won't change, and then I just multiply the third row by 1/2. When I do that, the left-hand side becomes 0, 0, 1, and the right-hand side becomes 7 over 2, 3 over 2, and 1/2. I now need to work on getting zeros above this 1. For the first one, I'm going to do 2 row 3 plus row 1. Our third row isn't going to change here. 0 times 2 is 0, plus 1 is 1. 2 times 0 is 0, plus 0 is 0. And 2 times 1 is 2, minus 2 is 0. On the right-hand side, 2 times 7 over 2 is 7, plus 1 is 8. 2 times 3 over 2 is 3, plus 0 is 3. And 2 times 1/2 is 1, plus 0 is 1. I now need to do my second row. For that, I'm going to do 2 row 3 plus row 2. 2 times 0 is 0, plus 0 is 0. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, minus 2 is 0. 2 times 7 over 2 is 7, plus 3 is 10. 2 times 3 over 2 is 3, plus 1 is 4. And 2 times 1/2 is 1, plus 0 is 1. So now I have the identity matrix on the left, and this matrix right here on the right is my A inverse, exactly what I needed. Let's try one more of these. Here I have my matrix, and I want to try to find the inverse. So I start by augmenting it with this on the left and the identity on the right. We start by getting a 1 in the first row, first column. In this case, we already have that. So we'll start with getting zeros below it. For the first one, we'll do 4 row 1 plus row 2. I know the first row here won't change. I then have 4 times 1 is 4, minus 4 is 0. 4 times 2 is 8, minus 7 is 1. 4 times negative 1 is negative 4, plus 3 is negative 1. On the right, I have 4 times 1 is 4, plus 0 is 4. 4 times 0 is 0, plus 1 is 1. And 4 times 0 is 0, plus 0 is 0. I'm now going to move to my third row. For this one, I'm going to do 2 row 1 plus row 3. 2 times 1 is 2, minus 2 is 0. 2 times 2 is 4, minus 6 is negative 2. 2 times negative 1 is negative 2, plus 4 is 2. 2 times 1 is 2, plus 0 is 2. 2 times 0 is 0, plus 0 is 0. And then 2 times 0 is 0, plus 1 is 1. My first column is the way I want it, so we'll move to the second column. We already have a 1 in the second row, second column, so we need to get zeros above and below this. And this time I'm going to start with that second 0, the row 3 0. I'll do 2 row 2 plus row 3. I know the second row here won't change. I then have 2 times 0 is 0, plus 0 is 0. 2 times 1 is 2, minus 2 is 0. And 2 times -1 is -2, plus 2 is 0. And I'm going to go ahead and stop right here. Because we see this row of zeros, we know this is not the identity matrix. I'm not going to be able to reduce this to the identity matrix. So this particular matrix doesn't have an inverse since I was not able to row reduce it to the identity matrix.